Hello, I'm Paul Merrill. I'm from Beaufort Fairmont Automated Testing Services, and today I'm here to talk about what's an API and how do I test it. My Twitter handle is on here, dpaulmerrill. A little bit about me: I'm the CEO and Principal Software Engineer in Test at Beaufort Fairmont. We work together with our clients on test automation. We focus on that world. We eat, sleep, live, and breathe the stuff. So when you've got questions or thoughts about test automation, when you've got challenges ahead of you with test automation, we're the people to come and talk to. And I want to talk to you about that. So some of the things that we do at Beaufort Fairmont, we help companies with problems like, I want to get dev and testing synced up in my agile environment. Things like, I want to automate regression testing in my environment. We like helping with those. We do that through three basic mechanisms. One is consulting, one is training, and one is project work or helping you staff. So we work all across the United States with this, with companies all over. So give me a call when you're ready for that. You see our number down here at the bottom. Let's get talking about some APIs. So a couple things coming up. Today is the 22nd of June in 2017, and tonight there's a meetup in Cary that I'll be speaking at about agile testing and a mechanism that I like to use, or a pattern that I like to use with organizations, called From the Inside Out. In July, we'll have our next webinar, and I'm going to talk about making the case for full-time test automation engineers. And I found recently that a lot of companies have trouble with this. We have a difficult time thinking about the role of the test automation engineer and what it means. We have trouble thinking about the responsibilities of a test automation engineer and relating those to other fields. Recently, I had the thought that the number of responsibilities I have when I play the part of test automation engineer is greater than the number of responsibilities I had as a software development engineer. That's not to say one is better than the other or one is more than the other. It's just that the number of responsibilities was greater. Let me put that into context. Consider the fact that for test automation engineers, we generally expect them to maintain a code base and create new functionality with that code base. How often do we expect the same of our developers? Now, small companies, yes, lots of times we expect the same of our developers. But as companies grow, it's more rare that that's the case. Many times people specialize as software developers in maintaining code or in working on new feature development. And that's because each takes a lot of effort. But for some reason, we believe that test automation engineers should do both. Not only that, developers tend to be able to hand off code to some type of support mechanism, customer support or something along those lines, customer success. Test automation engineers generally don't get to do that. They are the sole supporters of their code base, of their product throughout the organization. So they have testers coming to them, they have test automation engineers coming to them, they have developers coming to them, product owners, many others. So I just think that this role is one that we underestimate the amount of responsibility that's there, and we underestimate the amount of technical know-how, the amount of programming skills that need to be there in order to make this work well, and lessen maintenance over time. So I want to talk about making the case for full-time test automation engineers next in July. Machine learning is something that I'll be talking about, machine learning and how it affects agile environments, and I'll be doing that at the largest agile get-together in the country in Agile 2017 down in Orlando. So make sure in August to get out there, and if you're going to be there, say hi. I'd love to get to know you and meet you. I'll be there most of that week, getting to know people, listening to other sessions, and seeing some people that I've never gotten a chance to meet, and I'm very excited about. There are lots of great speakers down there that week. Lots of other stuff coming up. I'll be at Star West in October. I'll be at Star Canada in October, and a few others. So make sure to say hi if you're going to be at those. So the agenda for today, we'll talk about what's an API, we'll get into what REST is, and we'll talk about how we test an API. And I'm actually going to get in and demo some testing and creation of automated tests for APIs in this. So hang on, it won't all be slides. We'll get into examples very quickly here. So let's start out with what's an API. I'm not going to read all this to you. If you want the slides, send me an email, paul@beaufortfairmont.com. But the term API is an acronym for Application Programming Interface, API. And this is IBM API Connect, their definition of what an API is. They talk a lot here about exposing APIs to third parties and for them being public. APIs can be internal or external. Many times APIs are internal within development organizations or organizations with development teams, and that's because multiple different departments need to be able to work with each other and work on their products. The API economy is such that it's huge. It allows you to separate functionality and to have multiple teams working on things at multiple times, to run lots of things in parallel, and as long as we continue to have a consistent interface, we'll be okay with that. This is not going to be my end-all, be-all definition for APIs. I just wanted to give you what IBM had to say. Here's another way that they talk about it. And you can find all this on IBM API Connect. I have no reason to promote IBM, but they had some really great content on this, so make sure to Google that and look up the full content there. But basically, they're different from websites, although they function over, they may function over the web just like websites do, and we'll get into that in just a little bit. This is kind of my way of thinking about an API. An API is basically a collection of endpoints or services. It's a programming interface, meaning that it's a way of interacting with services, functionality, data. You can get data from APIs. You can use an API for functionality. And there are two big conventions right now on how we create APIs. The biggest ones at this point in time, to me, appear to be SOAP and REST. And let's see, so we'll talk today mostly about REST because that seems to be the most popular one, but you may have heard many different terms related to APIs. So what is REST? REST is representational state transfer. So that's what REST stands for. You get the RE from the representational word, and then state is the S, and transfer is the last one. There's a really great paper that kicked all of this off. It was a dissertation by a man named Roy Thomas Fielding in 2002 at the University of Berkeley in California. University of California, Berkeley, excuse me. And so he was working on his PhD, put this paper out, and I've got a reference to it here at the end of the slides I'll be happy to share with you. And he defined the terms for REST, and 6 of those constraints, or the 6 main constraints, are these: that we provide a uniform interface, meaning we know how to interact with this API uniformly, that one endpoint doesn't act differently than another, that they are stateless, they're cacheable, that we follow a client-server type of model, that there may be layered systems, and optionally code on demand. So read that paper for more information. If you look up Roy Thomas Fielding, 2002, University of California at Berkeley, you'll find it very quickly, and it's referenced all over the place. So usually, though, REST is considered to be an API that runs over HTTP, just like the rest of the internet, just like how we visit websites, those types of things. You've seen HTTP / whatever for 20 years now in getting on the internet. So HTTP is the protocol that we run many of these over these days. JSON tends to look like the most popular format that we use for the data that is transferred within APIs. So we're going to get into both of those as well. Let's lay a foundation for what we're going to talk about later. HTTP is based on a kind of simple idea that you have a client on one side, you have a server on another. You make a request from the client over to the server responds with a response to the client. This is what happens when you click go or send or submit on a web page or on the URL. If you hit enter in the location bar of your browser, the client that most of us know the best is our web browser. So Chrome, Edge, IE, Firefox, Safari, these are all clients. There are many other clients. Many times our phones serve as clients, and native applications on our phones serve as clients. The web browsers on our phones serve as clients. Other APIs can serve as clients. Other applications can serve as clients. So there are many different clients here, and we're going to get into a few of them as we go along here. But this is the basis for how HTTP works. It's the basis for how most APIs work today. HTTP functions on a few different methods. There's a list of them that I think it's about a dozen long. These are the ones that you may have heard of. GET means when I send a request, I'm expecting to get information back. POST means I'm submitting some type of information to a server, likely new information. PUT means that I'm trying to update information. Delete means that I'm trying to delete information on a server or service somewhere. There are more of these. I'm not going to get into all of them, but those might be the most familiar to you if you've heard of HTTP request methods. So let's dig in. How do I test it? How do I test an API? Let's dive into some code. So I'm going to switch around here. I'm going to switch my screens, and hopefully you can follow along. You'll see me looking off to the side here as I'm going along. I just recently did this same presentation live with a bunch of folks on today, the 22nd of June in 2017 at about 1 o'clock. This is a recording I'm doing after that, and those of you who missed it, hopefully I'll be able to share exactly the same information. We had a lot of really good questions during that session, and as they come up, as I think about them, I'll share them with you. But when you're in the live session, you get the opportunity to make sure that you hear what other people are asking, and many times people have the same questions that you do or questions you don't, and you can learn from those as well. So I strongly encourage people to take a look at the live sessions, to come out to the live sessions when they're happening. Once again, our next one will be in July, and I'm looking forward to that. Those are usually around 1 o'clock Eastern time. So let's see, let me get out of this. I want you to see my screen here. Hopefully you're looking at the main screen and seeing my invoice application. So one of my guys got in and created this application. It's a RESTful application on the back end, RESTful API on the back end, and on the front end we've got a web UI that's written, I believe, in Angular. He did a terrific job with this, and we're going to walk through it a little bit. So this is an invoice manager, basically something to maintain a company's invoices with, and this page would generally show invoices in it if we had any. We can go into this section and add invoices in here, mark it as paid or not or whatever, create, and you see that we've now got a row of data in here. We can go in and delete that invoice and see that that is gone. Now the API behind it we can actually call in a browser. I mentioned before we're functioning in RESTful APIs much the same as we do in a web browser. And so I'm going to actually use a web browser to call that API, and I just did. When I hit enter, it calls that API and we get a list of no invoices back. So this is the invoices endpoint, and it will return all the invoices in the system. At this point we have none. So let's create one like we did before. And this one I'm just going to type in some ugly data here. And you see that it shows up as a row in this table. Let's go back to our browser window that had a call to the endpoint in here. Refresh this, in other words, make that call again to that endpoint, to that service. And we see that we get data back. Oops, I wanted to not show you all of this right here. Let me, okay, pretend like you're not watching. I wanted to do this exactly like you all would see it. So let's go back and refresh. Right, so when you call that endpoint right now, this is what we get back. It's kind of ugly. We see a bunch of curly braces and colons and things like that. Not very human readable, but better than it could be, believe me. And what we have here is a series of key value pairings. So this is JSON, and JSON is JavaScript Object Notation is what it stands for. What we have there is key value pairings, and they are paired by this colon here. Each key value pairing is delimited by a comma, so you see several key value pairings, and then each instance of the object is, or of the data representation of an object, is delimited by curly braces. And we have an array of these, we can tell, or a list is another way to think about this, with these square brackets. So right now we only have one of these invoices, so we see it here. And we notice here that the data is exactly the same as what we saw over here. So let's add another invoice and make sure that we know what's going to happen here. I'm just going to add some more kind of ugly random data. Hit create. We see that we've got 2 rows there. Now when we go back we should have 2 rows, and we do. And you can see that this kind of, you can see it almost like it's rows here, but it's still pretty ugly. Let me add another one and show you how this can very quickly very quickly get out of control. All right, so now we can see this data in here. It looks a little bit different. Let's go back to our call to the API. All right, so now this is starting to get a little ugly, right? Because now this first instance here, this first object wraps all the way around to the next line. It's not as easy to see. It's not all lined up like the other ones are. You can see very quickly that if I do this with the browser, so the sizing of the browser affects it, all that. So let's talk about how we can make this pretty. And that's one of the things that you saw if you were actually looking when I told you not to earlier, and hopefully you didn't do that. So what I did was I went out and used an extension for Chrome. It's called JSON View. You can go out and grab that very easily from Chrome and add it in. And when I add that in and go back and make this request again, it starts to look a little prettier. Hopefully you believe that's the case. I think this looks quite a bit nicer here. So we've kind of got a nicely delimited, nicely shown set of data. We can see that this whole one is the first invoice, and this is the next invoice, and this is the next one. We can see each of the items in the invoice, and down here at the bottom, hopefully you can see on the bottom left there, that when we click on one of these, like the invoice, or when we highlight it, it shows us how in JavaScript to access that member of that JSON object. So that's really powerful as well and can help you in looking through these things. So we've kind of seen how to call an API. We've done gets against it through the browser. There are lots of other ways to do this. So let's talk about one of them. One of them, the very most basic one, I think, is the command curl. So if you're familiar with the command line, you've probably used curl before. It's available in Linux and Unix and Mac OS X by default. But Windows, it's usually not available by default, but you can go out and get it as a command. Download the exe for it. So curl allows you to go get things off the web, and so we can take the very same URL, paste it in there, and boom, we get back exactly the same data. Now there's no return carriage after this. It's pretty ugly, so it's putting that all on one line. There's no prettification that I've used here. Now there are applications and programs that you can use at the command line and pipe this through in order to make it prettier. Tools Node has, well, there are ones written in JavaScript that you can use Node to implement. There are other ones that are standalone. Python has a JSON prettification tool that you can use if you already have Python installed on your system. So there are lots of ways to do that. But we see that we get kind of this data back. Now there are some things that we can do if we want to test this. Let's clear the screen here and talk about it. So let's just say that we wanted to see if there was one field that we added in there, like the word Paul. Let's see if Paul is in there. And if I do a grep, it's going to come back with that entire row. Now there were other names that did not exist in there. We never put the word Steve in there, so just as a negative test case, we see that we did not get back that line of data. So you could potentially do a little bit of testing here with very little effort. You could use something like grep or lots of other filtering tools on the command line and make a little bit of headway with that. But you know, whether or not this makes sense for your environment, I don't know. I don't know what all you all have. Generally, there are tools that can give you more power than this and more abilities to do what you need to do with testing and test automation. So let's kind of put this out of the way and let's try some of those other tools. I mentioned, or I may have mentioned, the idea of Postman earlier. I want to look at Postman. So if you've never seen Postman, it's freely available out on the web. Go to Postman, I believe postman.io or postman.com, or just Google Postman. You can download it for free. There's a native app inside each of the major OSs. And what it does is it just allows us to create a request. So I'm going to put the very same URL into this bar. I'm using the get method. I mentioned earlier that there were a lot of different methods for HTTP. I want to show you some of those. When I do this drop down, it has all of them listed. So there's about a dozen there. And we talked about get and post and put and delete, but these are the other ones as well. So those are all available. Now, all I really have to do here for this particular endpoint is make sure that's specified as get, add the address there, and hit send. Boom, I get data back that looks a lot like what we saw before, except it's already pretty. So it has these tabs here. You can look at the raw return like we were seeing in curl. You can look at the prettified return here. Lots of different options. And you can also do this for other types of endpoints. So while the one that we're working on is JSON, it could be something that works only in XML. And if you select XML here and you select pretty, then it'll show pretty XML with all nice formatting so that it's easier to read. But our endpoint is in JSON, so that's the way that I've got this set up. You can look at the header, understand what came back on the response, all that type of thing. Set up the authorization here. All the different authorizations, our major authorizations are listed, and it will help you set those up. We talked a little bit about the idea of tests. So, you know, one thing you could certainly do in here is just kind of do searches for certain text, like Paul's. Let's see if I can type this, Paul's software. You could look for Paul's software company, things like that, and by hand go through and check what works and what doesn't work. But that's a little time consuming, and this offers some features, this tool offers some features like the ability to create tests, and it actually comes out of the box with the ability to just pop tests into here very easily. So let's just say that we wanted to look for a particular string in the body. So I'm going to do a negative test case real quick. We know that string you want to search is not in the text that comes back on the request. So let's just make sure as a baseline that it fails when we're looking for that. So we send and it failed, so that's a good thing. We know that that failed. But I could look for Paul's software, and we should get a positive response, a pass, right? And then you can name the test by saying Paul's software exists in response body. Okay, so maybe that's the name of the test that we want. So it names it here. You can filter by passed and failed, and there are a lot of other options here for how to look through things. So I'll let you explore those on your own. There are a couple things that are kind of fun, like response time, making sure that an API or an endpoint responds in a certain time. So right here it's saying 200 milliseconds. We're lucky it responded that quickly. You could shave this down, and I'm changing the message and the value here, and let's just see if it responds then. Let's see when it fails. Let's try that and just see if we can get down to 50. See if it's that fast. Wow, this is really fast. I bet it's not 10 milliseconds fast though. So let's try this again and see what happens. All right, we finally made it fail. So lots of options with this. You can go in and change these things very easily. You can check specific values. Lots of opportunity. Check the status that it's a 200, and we already know that it's a 200 status. That means that we got something back. So those are some tests in Postman, and you can export these tests, and then you can run them using a tool called Newman, which is also available from Postman. And Newman will allow you to run these tests from the command line. And that gives you a lot of power. So you could obviously tie that into continuous integration. So your Bamboos or Jenkins or Circle CI or whatever, you could tie this into and run those very quickly. Some other nice things, and we're going to get into talking a little bit about documentation of APIs and tools that do that, like Swagger. But there is the ability to import a collection from Swagger. So if your developers have already created a Swagger site and they've got it all updated with all the right information, you could import a collection of requests, and we didn't talk about collections, I'll get to that in just a minute, but you could import all the requests from Swagger into Postman, which would give you all the requests that you could possibly make in a valid format, and you could write tests on those and very quickly be up and running using Newman on continuous integration with all of those requests and just a test or two to go along with them. So, so there's a lot of power here within Postman, I see why people like it. If you wanted to do that import from Swagger, you just go up here, click import, import from link, and add that in here. We didn't talk very much about collections. A collection is a very helpful tool where it just saves all of the. Let's create one. So we were making this. Where is this? We were making this request with here. We could save this into a new collection and call this get invoices, and we can add that to a collection, new collection. You'd want to name it better than that, and save it. And we see over here we've got new collection. So if I go in and delete this out, I've saved that, and I can go back and hit that, call it right here. It's got all my tests as well saved. So that's what a collection is, and collections can be shared. You can export a collection with the tools in here. There's an export button somewhere, probably in here somewhere. But there is an export thing here. Many times developers would have already created a collection with this, and they share it across developers. So if you're a tester asking the question, hey, do you guys use Postman, developers? Developers, do you have a collection that you already use? Can I get access to that? How can I add to it? Would you like me to add to it? Would you like me to stay away from it, create my own collection? Can I duplicate yours and use it in testing? And then testers, if you'll check it into source code control, your Git or your Mercurial or SVN Subversion, whatever it is, Team Foundation server, check that collection in. Then you can all share the same one and be working off of the same set of tests and requests. So lots of opportunities there to benefit from. So we've talked a little bit about Postman and the test there. I want to get into another way to do testing and test automation for collections. So I went ahead and wrote up a little bit of Java here for us. It's just one test case. The framework that I used is JUnit. So JUnit is just a unit testing tool, but you can use it for a lot more than that. The benefit that I'm getting from JUnit is the ability to do things before my test case with a setup method or a before method, a before attribute, and also to get the benefit of running tests. And by that I mean with JUnit, most of these tools, whether it's an IDE like Eclipse, which is what I'm using, or IntelliJ, which is what lots of people use, or any of these others, they have plugins, or they may be built with the ability to show JUnit tests very easily. And there's a big benefit to that, being able to just see the results here with a green bar or a red bar as opposed to having to read through a lot of text on the screen can be very helpful. So that's why I've chosen to use JUnit. It also gives me the ability to go in and validate things. So doing assertions saying, I expect this to equal that, those types of things. So that's what I'm using JUnit for. So this is a very simple test case. We use the setup method to create a URL. That URL is going to look like the URL that we had. I'm kind of masking out a couple things here. I'll go in and show you what API IP looks like. That's that IP address that you saw in all the calls to the other import points. You also saw the API port, which is 808081 being called here. And I'm just kind of concatenating a string together with those, and then the invoices resource on the end there. I use that URL in order to open a connection. So here is my connection that I'm creating. And I did that in a setup because as we write more test cases for this endpoint, we'd like to use those same connections and the same URL again and again, or create it the same way each time would be a better way to say that, more accurate way to say that. So my test is called test get invoices returns 200 status. All I'm doing is checking the status code on this test and showing how easy that is. So on my request, I'm setting the get method. That's what we were using before, you remember. I call connect, and that makes the request out to the service, and we can investigate the response by doing things like this. So get response code. We'll get the response code, and we're putting that into a variable called actual response code. So that's the real one that we get back from the server. I've also got this expected response code, and that's basically for our testing. We say we're expecting a 200 code back. This is what we actually got back, is this actual response code. So the first part of this assert equals is just a log message in case it fails. The second part is an expected response code, the one we're expecting, and it's going to compare that to this actual response code. So let's run this test case and see if it works. It should. And it did. You saw that it turned green very quickly. I can rerun that. It'll turn green again. We can do that all day. It'll keep turning green. Another way to run this is a Maven project, and you're more than welcome to go out and grab this on GitHub. What I will tell you is that these URLs will not work for you most likely unless you're out there basically today or tonight. I'll be turning off this instance. I don't run them all the time. I just run them when I need them. So this API IP address won't be right. But if you want to test out this code against my invoices code, I'd be happy to let you. Just send me an email, paul@beaufortfairmont.com, or tweet to me, dpaulmerrill, or whatever, and I'd be happy to set you up a window of time on which you can use the exact IPs, and I'll update the code to have that in it so that you can try this out on your own. You could also very easily just go in and change this hard code in, you know, a well-known IP address or well-known address with that would respond with a 200. So an API that's out there that could respond with a 200, or a website in general, just anything, any website you could put out there, and it would return the same thing. So that's how you could do this in code with Java. So you know, and once you're in a tool like JUnit or running some type of test automation, you have the opportunity to run that on continuous integration just like you would anything else, any other tests. So that's kind of that. The code for that I wanted to share with you. You can find it on GitHub. So I'm DPM3354 on GitHub, and you can find this one. Oh, come on. Invoices API test is what it is. And all of these resources are listed in the resources page at the end of this presentation. And if you want the presentation and all the references, email me for that as well. So let's see. I think we've gone through everything I wanted to go through here on kind of how to test APIs. There's lots of ways to do this. Why would you want to test an API? That was one of the questions that came up. A lot of times these days we're using APIs in order to make functionality available to more than one client. We talked a little bit about what clients might be. So if you're in a company, for instance, that has a mobile app and a web app, and they're both calling the same API, would you rather write UI tests for both of those to test the functionality that's actually in the API, or would you rather write a test that goes directly against the API? Well, you get your bang for your buck if you go directly at the API. Many times they're much faster to write than test cases that are written for the UI. So UI test cases can be terrific. There are really good things about them, but they generally take a long time to write. They have more code than a service layer test like this would be. They take more maintenance because there's more code involved. They're more brittle because the UIs tend to change more often. They generally run much faster because all we don't have to render a UI. We don't have to do any of those things. Sometimes these can even be run in memory on developers' machines, given you have the proper setup. I know .NET allows that, and I would imagine Java does, possibly through one of the many frameworks out there to spin up a kind of embedded server to run that on your local development machine. And that gives you some other benefits. You don't have to clog up the network with these calls and stuff, although these calls are pretty small. So, or wait on network latency would be another one of those things. I think that's pretty much all I wanted to get out here. I'm trying to remember some of the questions that folks asked while I was presenting this live earlier, and I just don't remember them right now. So let me do this. Let me switch us back over to this other screen and kind of close this out here. I want to make sure you all have my information. So we dived into this. I want to make sure you have the references here. I mentioned a couple of these as we were going along. I mentioned Roy Thomas Fielding and his dissertation. This is a link to that. And the title of it, you could go look it up on Google that way, or ask me for the slides. I'd be happy to send them. What is an API in English, please? That was a nice little blog post. Here's something about how you get started with Postman, the first request. What is an API? I mentioned IBM API Connect and the wonderful resources from there. The resources that we use for Postman, we didn't use Newman, but I talked about it. This is the command line tool for Postman. Curl is one of the tools we use. Swagger, was the documentation tool that I mentioned. In fact, why don't I just very quickly show you what Swagger looks like. I meant to do that. So let me do that very quickly. I know that you're looking at the screen over here. Hopefully I can do this. So Swagger is at swagger.io. That's where you would go to get it and download it. There is an example implementation of Swagger on here, petstore.swagger.io, and in there you have the actual calls and how you would do each of these calls for each of these endpoints. So it gives you the ability to do things like go in here and actually try out a call to this endpoint, and I just did that when I clicked execute. Here's the response that we got back. There's some really strange pet names in here, but these are all the pet names they have in here. So fun stuff. And the way I mentioned, you could export this over to Postman. The way that you would do that is use this URL right here for the import URL on Postman, and that would do it for you. So that's what Swagger is. Let me get back over to my slides here. We talked about Swagger. The Chrome plugin that I used was JSON View. My code is up on GitHub at dpm3354/invoices_API_test. I'm always open to chatting. One of the things that we found very beneficial for folks is to spend about an hour talking about what their challenges are with test automation. And I love doing that. I learn a lot through it, and I can generally help companies and teams a lot during the course of just an hour. So if you have challenges or questions or thoughts, or you want to brainstorm about your test automation or talk through an experience that you've had, I would love to talk to you. You can always call us for that. We're not always able to answer the phone, so make sure to leave a voicemail there, but 984-244-2313 is our number. Find more of these webinars, beaufortfairmont.com/webinars. A lot of my writing is out on the blog site there as well, beaufortfairmont.com/blog. My email, paul@beaufortfairmont.com. Find me on Twitter and follow me on Twitter, dpaulmerrill on Twitter. I love to talk about testing on there. I love to hear about your thoughts and have discussions on there, as long as it doesn't get too deep, because then it's hard to talk in 140 characters. But the testing community is very strong on Twitter, so get on there yourself if you're not already. But yeah, I always offer a free conversation about what you're doing, and if I can help you during that time, that's great. If we need to do something more together and we find that, I would love it, and it's perfectly fine if we have a conversation and we find out that there's no need to move any further with that. I'm happy to have conversations just to kind of talk through where you're at for free for that hour. So make sure to give me a yell, reach out to me through any of these other mechanisms, Paul@BeaufortFairmont if you want the slides. And I really appreciate your time today and for listening through to the end. Let me know what I can do for you. Send me feedback about this webinar one way or the other. And thanks for being here. The next one, it will be July the 13th, I believe. And we tend to have these every month. So make sure to check out beaufortfairmont.com/webinars for more of these and for recordings of these as well. Thank you very much, and I will talk to you soon.